Breaking news. It's a very sad day in the statistics world.
Why is that, Mackenzie?
I have just received a report that it is the anniversary of the death of Gertrude Mary Cox.
Gertrude Mary Cox was born in Daytona, Iowa on January 13th, 1900, but she died on this day, October 17th, 1978.
When questioned, Gertrude Mary Cox told reporters why she joined the statistics world. She said, "Because I liked it and I could elect all the psychology I needed. I landed a job in a computing lab, which is how I got interested in statistics."
Fabulous, fabulous, fabulous. Some of her contributions to math included being the founder of the Department of Experimental Statistics at North Carolina State University. Go Wolfpack. Also, she was the appointed director of the Institute of Statistics at the Consolidated University of North Carolina and Statistics Research Division of North Carolina State University. Again, go Wolfpack.
Woo! Cox also wrote a book about experimental design in the 1950s. She served as president of the American Statistical Association, ASA, in 1956 and the International Biometric Society from 1968 to 1969.
But Mackenzie, we cannot forget that she was also elected a member of the prestigious National Academy of Sciences in 1975, but was also a fellow of three other prominent organizations, which is the Royal Statistical Society, the American Statistical Association, and the Institute of Mathematical Statistics.
We cannot forget that.
Cannot forget that. But last but surely not least, she helped found the Research Triangle Institute in North Carolina.
Now you may be wondering, why does this relate to statistics? Well, I have an answer for you, my good people. Gertrude Mary Cox was considered the first lady of statistics. She represents Michelle Obama in a mathematical light. Gertrude Mary Cox emphasized experimental design. She also emphasized randomization and replication, all also very important, and she improved control and accuracy of experiments. She improved them very well, and now experiments can run with accuracy.
Very true, and she was awarded for these contributions to
Oh, yes, she was, because she
fabulous.
was great.
Gertrude Mary Cox had many contributions that Mackenzie just told us about because she was a wonderful woman. Wonderful. So, to show its appreciation, NC State, go Wolfpack, honored Cox for her contributions by awarding her the Watauga Medal in 1977 and naming Cox Hall in her honor. The University of North Carolina system paid tribute to her by naming her the Max Gardner Award recipient in 1959. How wonderful is this woman, Mackenzie?
Oh, she is fantabulous.
Beautiful.
I really wish I got to meet her.
Well, folks, that is all we have today. Thank you for joining us.
So, 6A asks, does the scatter plot support the newspaper report about number of semesters and starting salary? Justify your answer.
We said that the scatter plot does support the newspaper report because as the number of semesters increases, so does the pay in thousands of euros, and it provides a positive correlation.
If you look at the scatter plot, you will see that as number of semesters increases, generally so does pay. 6B, identify the slope of the least squares regression line and interpret the slope in context.
We said that the slope of the least squares regression line is 1.1594, which means when x equals the number of semesters increasing by 1, the starting salary increases by $1,159.40 on average.
It's euros, but it's okay.
Oh shoot, euros, my bad.
Okay. Anyways. 6C, based on the people in the sample, describe the association between starting salary and number of semesters for the business majors.
We said that the starting salary and the number of semesters for business majors has a strong negative association.
This is because if you look at the circles,
which means business,
according to our glorious key, you can see that it's like relatively a straight line, but you know it's not quite there yet, but it's going down, so that means it's negative. Okay, 60. Based on the people in this sample, compare the median starting salaries for the 3 majors.
The median starting salary for business majors is about 39,000 euros and is less than the 2 other majors. The physics major is roughly 50,000 euros, and the chemistry major has the largest starting salary at around 56,000 euros.
This is calculated by, if you look at the scatter plot and you count the number of points and find roughly where you think the middle point would be, and you go across and estimate where that value would correlate to that point. And then if you look at the plot, obviously business has less, and then physics, and then chemistry. It is important to make sure that you actually compare the 3 instead of just saying, you know, business is this one and then physics is that. Based on the analysis conducted by the independent researcher, how could the newspaper report be modified to give a better description of the relationship between the number of semesters and starting salary for the people in the sample?
We said that the report should take into account the type of major that is being pursued, as some majors may require more semesters to be taken. According to the data, more semesters taken usually results in higher starting salaries, and less semesters yield a lower starting salary.
It is important for this question to incorporate how the experiment could be modified, therefore not repeating the exact same experiment that was conducted, and you also want to describe the relationship between the number of semesters and starting salary for the people in the sample. So again, if you look at your scatter plot, which I just zoomed in on, as the number of semesters increases, usually starting salary increases, except for a couple points where, you know, maybe it wasn't quite as high as it should have been, but that is a-okay.
Okay, so for grading, we would say for part A, we would give it 1 point because it is just asking whether the scatter plot does support the newspaper report or it does not, and we just have to justify our answer. Part B, we would say, is 2 points for correctly identifying the slope and also interpreting the slope in context.
It is important to read your question and count out the points that it's asking you to do. So like how this one says identify, that's 1 point, and then interpreting is another thing, so you need to do both and not just one half of the question, or Mr. Allen will get very mad at you.
Part C, we would give just 1 point because we are describing if it has a positive association or a negative association. Part D would also be, it would be 2 points for correctly comparing both or all 3 of the majors, and since this calls for somewhat a longer explanation, it would be worth 2 points. And then Part E would be 2 points because why, Mackenzie?
Oh, because you need to provide a description of another way that the experiment could be modified, so that's 1 point. And then you also kind of want to talk about the relationship between the number of semesters and starting salary, because that's what the question is asking you, is to think of another way where you could get a better description of the relationship. So you kind of want to mention, what that relationship is. We hope you found this video very entertaining and very useful, and there will be more funny clips in the blooper section, so please stay tuned.